I see you're up to physics again.
Hi, I'd like to go over a question with you on the law of linear momentum. Let's have a look.
Okay.
We have a clay ball, and it's 40 grams, moving at an unknown velocity. And it's going to hit this block of wood. That's 160 grams, and it's going to stick to it. And it's going to swing upward. There is the whole block and clay system, and it goes up 5 centimeters. Easy enough. You might have learned in class this is known as the ballistic pendulum. What I want to do is two things. I want to find the speed of the ball before it strikes the block, and I want to find the kinetic energy of the system after the collision. Anytime there is a collision, I want you to entertain the law of linear momentum that says the momentum before, notice P with an arrow stands for momentum. The arrow means it's a vector. The momentum before the collision equals the momentum after the collision. Momentum is the product of mass times velocity. So it's going to be the momentum of the ball plus the momentum of the block of wood equals the total momentum. Because it sticks together, this is what we call a totally inelastic collision. So therefore, I write big M. The big M is going to be the total mass, the 160 and the 40, and this is V after. All right, let's plug in. M1, V1, you're going to use kilograms. 40 grams is 40 kilograms. V1, we don't know. The block is stationary, so this term comes to 0. The total mass is the 0.160 plus the 0.40 times V after the collision, which we don't know either. So we have two unknowns. We have 040 V1 equals 0.20 V after, divide by 040, and we get the equation V1 is 5 V after. Now what? We're now down here. All the kinetic energy at the bottom is going to become potential energy at the top. So we can say the kinetic energy lost at the bottom is equal to the gain in the potential energy at the top. So we are going to set 1/2 of big M V after squared equals mgh. The m's drop out. So it's 1/2 V after squared is gh. Bring the 2 to the other side, square root it, and you get the velocity after the collision is the square root of 2g. There's the height. 5 centimeters is 05 meters. We get 0.99 meters per second. Without a calculator, we would have got 1. Now that we know that V after the collision, we can go back and get V1. V1 is 5 V after, gives me 4.95 meters per second. And then part B, the kinetic energy after the collision is 1/2, there's the total mass, times the velocity after the collision, 0.99 and square it, and we get 0.1 joules. And there you have it. That's the way you would go about doing a problem involving momentum. Keep in mind, if you ever see a collision, entertain the possibility of a momentum question. If they stick together, we call it perfectly inelastic.
Wow, Dr. Romano, another great problem. Are you going to put up any more biology questions or
Well,
gen
I have a
chem?
lot more free videos coming down. Think free. Bye-bye.
Everything's free, Dr. Romano. We like that. Good day to you, sir.